Good morning to everyone. So yesterday we discussed this problem. Evaluate the function u of x comma y satisfying del square u equal to 0 at the lattice points given the boundary values as shown. I think we got 4 equations from these from the table. Okay, so just I will write the 4 equations again. Please check it. For u1 for u1 minus u2 minus u3 is equal to 3000, and the u1 minus 4u2 minus 4u2 plus u4 equal to minus 1500. Third equation, u1 minus 4u3 plus u4 equal to minus 2500, and then u2 plus u3 minus 4u4 equal to 0. So I told to you, try to solve this 4 equation and find the values of u1, u2, u3, u4. So what is the value of u1? Okay. So otherwise, we should eliminate u1 from 1 and 2. If we eliminate u1 from 1 and 2, we get 4u1 minus u2 minus u3 is equal to 3000. This is actually 1. Multiply equation 2 by 4, you will get 4u1 minus 16u2 and then plus 4u4 equal to minus 6000. So minus plus minus plus, you'll get 15u2 plus sorry, how many u3? Okay, minus u3 minus u3. This is u3, this is u4. So minus u3 minus 4u4 which is equal to 9000. I call this is equation number 5. Now again eliminate u1 from 2 and 3. So you write 2. 2 is u1 minus 4u2 plus u4 equal to minus 1500. And U3 is U1 minus 4 U3 plus U4 equal to minus 2500. Okay, so now if you subtract, you get minus, here we get plus, minus, plus. So this is cancelled. This is U2, this is U3. So you should be very careful. So don't cancel this one. So minus 4U2 plus 4U3. I think these two are cancelled, which is equal to 1000. I call this is 6. Now eliminate U4 from 4 and 5. So if you just subtract, you'll get in U2 and U3. Here you have U2 and U3. Okay, then you can find U2 or U3. So first you should eliminate U4 from 4 and 5. What is 4? 4 is U2 plus U3 minus U4. This is actually 4, and 5 is 15U2 minus U3 minus 4U4 equal to 9000. This is 5 minus plus plus minus. So minus 14U2 plus U2 plus 2U3. So U4 gets cancelled. So minus 9000. This is 7. This is 7. Now from 6 and 7, what is 6? Minus 4U2 plus 4U3 equal to 1000. Minus 4U2 plus 4U3 equal to 1000. This is actually 6. Multiply 7, equation 7 by 2, minus 28 U2 plus 4U3 equal to minus 18,000. So if you subtract, get plus, minus, plus. So 24 U2 equal to 19,000. So U2 equal to, so using calculator, please verify and tell.
791.666.
Okay, 791.666. So that's why I'll write 7. Check. Okay, now remaining values you should find out. U3 or U1 or U4, you can substitute, and now you can tell easily.
Sir, U1 1208.331.
1, 2, 0.008.331.
331.
Okay. Okay, but the book answer is 4. Okay, I'll write, but you can't write 4. If it is 331, you can't write 4. Okay, I'll write 3. What about
U3 1041
U3 is 1.
041. U3, sir.
Uh, Please check it once again. U3 1041 or 1341.
1041.
1041.7.
1041.7.
0.7.
This is the book answer. Okay. I think we got U2, U1, U3, and the only thing U4.
458.4.
Yes, correct. 4, sorry. 4. Okay, thank you. 458.4. Okay. So actually, I told that already. This is method 1. Method 1. I just explain you method 2. Sorry. Method 2. So again, I need to go to the table. So in method 2, uh, okay. So I need to assume any one of U1 or U2, U3, U4 value. At least one of the value I need to assume. Because even if you use diagonal 5-point formula, okay, for U1, I think we know 1000 and 2000, but we don't know U4. Okay, so that's why either you should assume U1 or U2 or U3 or U4. So now I am going to assume U4. Okay, this is for method 2. I am explaining. This is for method 2. Okay. Now U4 lies in this vertical line. So 0 to 1000. So U4 should be in between 0 to 1000. And also U4 lies the horizontal line. So 0 to 2000. So again, it lies between U4 should be 0 to 2000. So you should choose uh, U4. If you choose U4 is 0, the number of iteration is uh, large. You need to do at least of 6, 7, 8, 9 iteration, then only you'll get the answer. So to avoid the this, so you should assume, so U4 equal to, okay, let us check. U4 may be like this: 0 plus 0. I am taking this one, this vertical line, 0 plus one third of the distance, because 1, 2, 3. So U4 is one third of 1000 minus 100. Sorry, 1000 minus 0. So which is nearly equal to 333. So okay, now if you take this line, suppose here it is 1,000, then you can take this is around 300 or 350, or even take 333. Okay, now otherwise, if you take the vertical line, 0 plus one third of the distance from 2000 minus 1000. So this is nothing but 666, nearly equal to 666. Okay, so my suggestion, it is better to assume average of these two. Okay, so 666, so 999, so divided by 2, so 1000, so 1000 means 500. So my suggestion is U4 equal to, you can take 500. But in the book, they are taking U4 equal to 400. So there is no logic behind U4 equal to 400. Okay, at least for choosing 500. So there is some logic because here I have triple three, you have triple six. So I'm taking the average 500. Okay. So even you can take it is a 400 or 500 or 450. Okay. 450. But don't take below 400, don't take above 500. So this is my suggestion. So once you fix u4 value, any one of them, uh, okay, so as per the book we will go. So I will take 400. Okay, now I will tell you method 2. Okay, but you need to form the equation. So I need a table value. Okay, so u1 equal to u1 equal to 1 by 4. Use diagonal 5-point formula. Okay. So if any one of them wrote this table in your notebook, please tell. I will write in the next page. Okay. So u1 equal to, you can tell 1 by 4 into what? Using diagonal 5-point formula.
1000
1000
plus
Yeah, 1000. Okay.
plus 1000
Okay.
plus 2000
Plus 2000. Okay.
plus U4.
U4, yes. Yeah, okay. U4. But U4 is, uh, I assumed this is 4000. 4000 plus 400. Even you can take 500 also. Okay. So I want to check book answer. That's why I'll take 400. So now you'll get 4400 divided by 4. So 1100. So this is a diagonal 5-point formula. And then U2. Similarly, tell U2.
1000
1000. Okay.
plus 1000
Okay.
plus 0
Plus 0. Or
plus
1000. Here you can use standard 5-point formula. Okay. Because you know that okay, I will tell you here, because here you can use standard, because u2 only thing you need 4 values, but we assume u4. Okay, u4. So 1000 plus 500 plus u4 plus u1. Okay, now you can tell.
okay, sir.
No problem. Okay, 1 by 4 plus 1000 plus 500.
Plus u4 plus u1.
Oh yeah, u4 plus u1. Okay, now this is equal to 1 by 4, 1500. U4 is what? 500. That is, we are sorry, 400. 400 we assume. U1 just we got it 1100. So what is the final answer for U2?
750.
Yes, 750. So here we are using standard 5-point formula, and then U3. So if any one of them can tell,
3000 plus
2000 plus
U2.
2000 plus U2,
U2
U2.
plus
uh,
1000
U3,
Sir,
I don't.
not u2, sir.
Yeah,
u1 plus u4
yeah, U1 plus U4.
plus 500.
Yes, plus 500. Here also we can use standard 5-point formula. Okay. So now this is equal to 1 by 4, 2500 plus U1. U1 is 1100 plus U4. What is U4? U4 we assumed 500. Sorry. Again, I will choose 500. Okay, 400. So I need the final answer for U3. This is 4000 divided by 4000.
1000.
Okay. 1000. This is here I am using standard 5-point formula. And finally U4 1 by 4. For U4 again standard 5-point formula, 0 plus 0 plus U2 plus U3. So for U2 you should choose 750. For U3 you can choose 1000. So 1 by 4, 750 plus 1000, 1750 divided by 4, what you will get?
437.5.
Okay, 437.5 using standard 5-point formula. So this is actually rough values because you are using diagonal 5-point formula. Okay, so if you use diagonal 5-point formula, that set of values you should assume it is a rough values. Now iteration 1, first iteration, second iteration, third iteration. So at least you should go in the book for this problem. So there were up to 5 iterations. So you know the answer. You already know the answer. Okay, because method 1 you got the answer. So try in your free time and try to get the same answer. Okay. So next problem, problem number 6. Solve uxx plus uyy equal to 0 for the following square mesh with the boundary condition as shown below. Iterate until the maximum difference between successive values at any grid point is less than 0.0001, the 001. The difference is very small between the two iterations. Okay, so this is a problem. Here you can see about this diagonal. For example, I put just a dotted line. About this diagonal. Okay, so 1 1 2 2. Similarly here 2 2 1 1. So symmetry with respect to this diagonal. Okay, so and hence u2 equal to u3. So both of them are same. Similarly, if you look at about this diagonal, okay, so you can see here 2 2 1 1 and 1 1 2 2. So and hence u1 equal to u4. So from the symmetry of using the symmetry of AC, we observe that u2 equal to u3. From the line of symmetry of BD, we observe that u1 equal to u4. u1 equal to u4. So it is enough to find. It is enough to find u1 and u2. Only these two is enough. Okay. So now method 1. Method 1. Okay. So u1 equal to, use standard 5-point formula, 1 by 4, 1 plus 1 2 u2 plus u3. But u2 plus, okay, I will write u2 plus u3. So but u2 equal to u3, so 1 by 4 2 plus 2 u2, since u3 equal to u2. So this is equal to, take 2 commonly and divide, cancel the 2. So 1 plus u2 divided by 2, which is equal to u1. So cross multiply, I will write here 2u1 2u1 minus u2, 2u1 minus u2. Okay, it's not clear. So 2u1 equal to 1 plus u2, or 2u1 minus u2 equal to 1. So this is 1. Similarly, I need to find u2. So u2 equal to 1 by 4, 1 by 4, 2 plus 2, 4, 2 plus 2, 4, plus u1 plus u3. Sorry, u1 plus u4. Okay, so this is equal to 1 by 4, 2 plus 2, 4, plus u1 equal to u4. We know that. So that is equal to 2u1. So take 2 commonly and cancel out. So 2 plus u1 divided by 2 equal to u2. So 2u2, this implies 2u2 equal to 2 plus u1. 2 plus u1, or u1 minus 2u2 equal to minus 2. So this is equation 2. So try to solve these two equations, and two unknowns, find the value of u1 and u2. So
U1 1.4.
u1 is 1 point, actually u1 is 1.4, 4 by 3. Yeah. Is it correct?
Yes, sir.
Yes, sir.
Okay, 4 by 3 is 1.3333 and so on. Okay, so you got this answer 1.4, because in book they are
1.333, sir.
okay. Okay, thank you. And then u2 equal to
1.66.
1.66.
okay 5 by 3, that is 1.6666. Okay, so I think we got the answer from using method 1. Okay, now method 2 again. I'll give the hint, you can try. Method 2. So uh, we should assume either u1 or u2. Okay, we should assume either u1 or u2. Okay, I will assume u2. Okay, so what is u2? You tell, what is u2? What values you can take u2? Because this is the vertical line, it is also the horizontal line. The endpoints are same here. Here also 1 2, here also 1 2. But in the previous problem is not in the same case. 0,000 something 2000 0. But here the values are same. So what is u2?
In
4
between
by 3.
1.5 and 2.
Uh, both of them are telling answer. I am not clearly. Somebody told. Please repeat. Sorry.
4 by 3.
4 by 3. Yeah. 4 by 3. 4 by 3 is equal to. Okay. Please check it. Actually, if it is 1, okay, 1 plus. I think you are correct. I'll check it. 2/3 of 2 by 3. 2/3 of distance into 2 minus 1. Okay, 1 plus 2 by 3. Not 4 by 1 plus 2 by 3. 1 plus 2 by 3 is 5 by 3. Okay, 5 by 3, not 4 by 3. Okay, so it should be 5 by 3. So you should assume like this. So 1. Okay, this is a u2 is a 2/3 of the distance from here, and then into the difference between bigger value and smaller value. 2 minus 1. So this is 1. So 1 plus 2 by 3 is 3 plus 2, 5 by 3. This is equal to 1.6, nearly 1.6. So I am going to assume U2 is 1.6. Okay, now U1, rough values. So rough values. U1 equal to 1 by 4. So can you tell from the table 1 plus 1, 1 plus 1 plus U2 plus U3 plus U2 plus U3 using standard 5-point formula. So 1 by 4, 2 plus, but we know that U2 equal to U3. So 1.6 plus 1.6. So final answer is 1.3. You can check it using calculator. And U2 again. U2 is 1 by 4 into U2 is 2 plus 2 using standard 5-point formula. U1 plus U4, which is equal to 1 by 4 into 4 plus U1 plus U4 is, both of them are same, which is equal to 1.3 plus 1.3. So the final answer is 1.65. So you know the values already, U1, U2. So first iteration, second iteration, at least you should go for 4 iteration, you will get the same answer. So I'll go to the next problem. Okay, here it is explained here. So the line of symmetry. Okay, so problem 7. Solve uxx plus uyy equal to 0 for the following square mesh with the boundary values are shown in the following the in the figure below. Okay, so here you can see the values are symmetrical about this diagonal only AC, not symmetrical about the line BD, only about this line. So 1 1 2 2 4 4 5 4. So if you take this line, this is not symmetrical. Okay, so only about AC. So if you take, this is U1. Okay, so about BD it is not symmetrical. That's why. Okay, so because about this line it is symmetry, that's why U2 equal to U3. U2 equal to U3. So it is enough to find U1, U2, and U4. Okay, method 1. U1 equal to using standard 5-point formula 1 by 4, 1 plus 1, 2, U2 plus U3. U2 plus U3 is I think they are not equal. They are equal. Okay, because the line of symmetry U2. Okay, I'll write U2 plus U3, but both of them are same. So 2U2. So if you cancel 1 plus U2 divided by 2, so 2U1 minus U2 equal to 1. This is equation number 1. Similarly, I need U2. So U2 equal to 1 by 4, 2 plus 4, 6 plus U1 plus U4. But U1 and U4 are different. So 4u2 equal to 6 plus u1 plus u4, or or u1 minus 4u2 plus u4 equal to minus 6. Minus 6. This is 2. And then I need u4. So u4 equal to 5 plus 5, 10. 1 by 4. So 10 plus u2 plus u3. But u2 equal to u3, we know that. So 2u2. So 5 plus u2 divided by 2. So 2u4 equal to 5 plus u2, or u2 minus 2u4 equal to minus 5. So this is 3. So 3 equations and 3 unknowns, u1, u2, u4. So please do it and tell the value of u1, u2 and u4.
U2 2.83.
Okay. So u2 is, please tell, I think u2 is 2, sorry, 3. Exactly 3, I book answer. Is it correct?
I got 2.83, sir.
Uh, 2.83. Okay, we'll check it. I think book answer is 3. So here have u1, u2. Okay, here have u1, u2, u4. Here have u2, u4. Okay, try to eliminate u1 from 1 and 3. If you eliminate u1, 1 and 3, you'll get u2 and u4. Okay, so I'll write 1 here. 1 is what? 2 u1. Okay. 2 u1 minus u2 equal to 1. Okay, multiply the second equation by 2. This is 1. 2 into, I'm multiplying by 2. This implies you get 2.
Sir, U2 equal to 3.
u2 equal to 3. Yeah. Okay. So you can easily verify. So you try and you can get it. So I will write the final answer on the next page. If you tell u2 equal to 3, okay. What about the remaining values?
U1 equal to 2.
u1 equal to 2, okay.
U4 equal to 4.
Okay. Yep. So this is the values in the book. So please verify. Okay. So now method 2. Method 2. So method 2, you need to assume any one of the UIs, otherwise you can't proceed. Okay, either using diagonal 5-point formula or a standard 5-point formula. So I'm going to assume U2 here. So if I assume U2, you can also use it for U3 also. That's why I'm going to assume U2. So what value you will assume for u2? It should be 2 and 5. It should, and also 1 and 4.
3.
Yeah, 3, correct. Okay, here because 2 plus one third of the distance. Okay, 5 minus 2. So 3 by 3, 1. So 1, 2 plus 1, 3. So similarly here, 1 plus one third of the distance, sorry, 2/3 of the distance from here into 4 minus 1. So this is 3 gets cancelled, 1 plus 2 is 3. So take u2 equal to 3 and then you should proceed. So rough values. So u1 and u2 and u4 are okay, u1, u2, u4. So I don't want to again explain this method because you know that, but you know the answer also. So you verify later. So next problem. Solve uxx plus uyy equal to 0 over the square mesh of side 4 units, satisfying the following boundary conditions. So here, uh, the diagram is not given in the question. Only these 4 equations are given. You need to draw the diagram for this problem. Okay, so u of 0 comma y equal to, actually they gave square mesh of side 4 units. So you will get a 4 cross 4 square. Okay, uh, satisfying the following boundary condition. Uh, so x0, x0 means y axis. Okay, y varies from 0 to 4. Y varies from 0 to y is 0. It is 0 comma 0. 0 comma 0 is 0. Similarly, 0 comma 1 is also 0. 0 comma 2 is 0. 0 comma 3 is 0. 0 comma 4 is 0. They wrote it is O, but actually that is a 0. Okay. And then u of 4 comma x is equal to 4. X is equal to 4 means this is the line, x is equal to 4. If y equal to 0, it is 12. So it is 12. So here, if we have y equal to 1, it is 12 plus 1, 13. Y equal to 2 means 12 plus 2, 14. Similarly, 15, 12 plus 4 is 16. So the boundary values are given in this equation. You should write these values. Similarly, u of x comma 0, that means y is 0. Y is 0 means x-axis. It is 3x. When x is equal to 0, it's 0. When x is equal to 1, 3 into 1, 3, and then 3 into 2, 6, 3 into 3, 9, 3 into 4, 12. And u of x comma 4 equal to x square. So when y equal to 4, this is the line y equal to 4. So x square, x varies from 0 to 4. So 0 square, 0, 1 square, 2 square, 3 square, 4 square. So once you write this table, the remaining part you should find, you'll check it, whether it is a symmetrical about this line or symmetrical about, if it is a 4 by 4 uh, squares. So you can check this line also, this line and this line and about this line and about this line. So nothing is a symmetry, means you should find all the line values u1 to u9. So that is already I explained to you. Okay, the first problem. Okay, so I don't want to repeat again. If at least if you want to find what is time now. So 10 more minutes. Okay. So you should start from where? First, you should find which value.
U5.
Yes, correct. So rough values, rough values. So you should start from U5. So U5 equal to 1 by 4. So I'll do only rough values. So if any one of them tell, then I'll write quickly. So 0 plus 4, 0 plus 4 plus 14 plus 6 are okay. 0 plus 4 plus 14 plus 6. This is equal to 6. Here I am using standard 5-point formula. So after U5, you need to find U1. For U1, you can't use diagonal 5-point formula because I don't know U2 and I don't know U4. So you should use the diagonal 5-point formula. You can't use standard 5-point formula. So U1 equal to 1 by 4 into 0 plus 0 plus 4 and U5 is 6 plus 0. So 10 by 4, that is equal to 2.5. This is a diagonal 5-point formula. And then U2, not U2, U3. U3, you should use diagonal 5-point formula. 4 plus 16, 4 plus 16 plus 14, 14 plus U5. U5 is 6. So you'll get 30, 40 by 4, 10. Here, diagonal 5-point formula. So next U, after U3, U7 and U9. Okay, U7. U7 equal to 1 by 4. Use diagonal 5-point formula. 0 plus 0, 0 plus 0 plus 6 plus U5. U5 is 6. So 12 by 4, 3. So diagonal 5-point formula, and then U7, U9. U9. U9 you should use again U5. U5 is 6 plus 14 plus 12 plus 6. So you get, please check it,
9.5.
29.5. Okay. This is diagonal 5-point formula. So now remaining U2, U4, U6, U8. So you should find using standard 5-point formula. Standard 5-point formula. SFPF, everything. So please check it. This is 5.625, 2.875. This is equal to 9.875. This is equal to 6.124. So for everything you should use standard 5-point formula. This is rough value. So at least you should go 2 iteration. So at least 2 iterations. So maximum 3 iterations. So depending upon the time, you can proceed. Uh, okay. So I'll start the next topic. At least I will explain you uh, Poisson equation. So Poisson equation is del square u equal to f of x comma y. Okay, del square u equal to f of x comma y. Del square u is what? Dou square u by dou x square plus dou square u by dou y square equal to f of x comma y. So this is a Poisson equation. So using numerical derivatives, so we derive this result. So the result is, you should remember this result. The equation number 2, ui minus 1 comma j plus u I plus 1 comma j plus ui comma j plus j minus 1 plus ui comma j plus 1 minus 4 uij equal to h square into f of ih comma jh. Okay. So now this is the problem. So solve del square u equal to, you can see here, f of x comma y. Okay, this is f of x comma y. So in the previous method Laplace equation, the right hand side is 0. Del square u equal to 0. So here you have del square u equal to minus 10 into x square plus y square plus 10 over the square mesh, with the sides x is equal to 0. X is equal to 0 means y axis. Okay, and y equal to 0 means x axis, and this is the line x is equal to 3. This is the line y equal to 3. So you should draw the diagram here. Okay, you should draw the diagram here with u equal to 0 on the boundary. So here u value 0, here u value 0, here all the boundary it is 0, u is 0. Okay, so that's why it is written here u equal to 0 means in all the 4 points u is 0. Similarly, u is 0 means in all the 4 points u is 0. Similarly here, similarly here. So with the u equal to 0 on the boundary, and the mesh length on 1 unit. So the distance is here 1. Here also it is 1. So it is given the question. Now you should find the value of u1, u2, u3 and u4. Okay. So just I will give the outline. We will discuss again this problem in next class. So this is a Poisson equation. This is a problem we discussed. Okay. So first, you should write the formula. Okay. So what is the formula? You should write this formula, and you should. I will write here u I minus 1 comma j. But the previous method without formula you can do it. But here you should know this formula ui minus 1 comma j plus ui plus 1 comma j plus I will write here ui comma j minus 1 plus ui comma j plus 1 minus 4 ui comma j equal to okay. So here del square u equal to what? Minus 10 into x square plus y square plus 10. It is given the question. Okay. But this formula you have, right hand side is what? H square into f of ih comma jh. But we know that h is equal to what? H is equal to 1. It is given. The mesh length 1. If h is equal to 1 means the right hand side is what? 1 square into f of I h is 1. So this is 1 into f of I comma j. Okay, so this is equal to h square 1 square into f of IH comma JH. But this is equal to, actually this is f of x comma y. Now we need to find f of I comma j from this. So minus 10 into I square plus j square plus 10. So now you should apply this formula, at D, at F, at G, at E. Okay, what is here I value and J value? At F, what is I comma I value and J value? If you tell, because here you consider this is I, this is J. So this is 1 comma 1. Okay, I is 1 and J is 1. What about here in G? I is 2, J is 1. Similarly here I is 1, J is 2. Here I is 1, J is 2. So I is 2, J is 2. Okay. So now you should apply this formula at the 4 points. You will get 4 equations and 4 unknowns. If you solve, you can get the final answer. Okay. So again, we will discuss this problem from the beginning in the next class. I think time is 9:45. Thank you. We will meet again on Saturday. If you have any doubts, you can ask to me. Otherwise, you can leave.